Welcome to Carlton's Math Corner. Today we're going to continue our study on multiplying fractions and mixed numbers. Our target today is that I can multiply mixed numbers without a calculator. So let's refresh our memory on how to change a mixed number into a fraction, because we're going to use this skill that we have learned in future problems today. And so looking at 5 3/7. Remember, a mixed number is a whole number plus a fractional part. And so remember, we're trying to figure out if I have 5 wholes of something, 5 whole pizzas, 5 whole rectangles, 5 whole pies, cookies, whatever. I am trying to figure out how many fractional parts in all would I have. Well, this bottom, our denominator, is going to tell us that basically our whole numbers are separated into 7 equal parts. So if I have 5 wholes and they are separated into 7 equal parts, how many fractional pieces do I have so far? Well, if I take 5 wholes times 7, that would get me to 35. So I have 35 sevenths, but then I have 3 additional parts. And so 3 additional parts means that I have 35 plus 3, 38 sevenths. So 38 sevenths would be equivalent to 5 3/7. So all I did is I took 5 times 7 plus 3 to add those additional parts, and I kept my denominator the same. So 38 sevenths is the improper fraction for 5 3/7. So let's use this knowledge and let's multiply some mixed numbers together. And so we're going to use these following steps. The first steps is we're going to change a mixed number to a fraction, and then we're going to use our skills from the last video on how to multiply fractions. So let's take a look at a couple problems. First of all, just refresh our memory. I would like for you to do one problem on your own of changing a mixed number to an improper fraction. What would 5 6/7 be equivalent to? What improper fraction would it be equivalent to? Well, 5 times 7 is 35, plus 6 is 41, 41 sevenths. Nice job. Now, let's take that knowledge and let's start multiplying some fractions and mixed numbers together. So here are some mixed numbers. And first of all, we have 7 1/5, and we have 3 1/6, and we're going to multiply them together. So let's do our first step, and that's to change them to improper fractions. So 7 1/5, what would that be? Yep, 7 times 5 is 35, plus 1 is 36. 36 fifths. How about 3 1/6? 3 times 6 is 18, plus 1 is 19. Nice job. And we keep the 6 because that's how many fractional pieces there are, or that's what they're created out of. So now we have 2 improper fractions, and now we're going to multiply them. So let's refresh our memory from the last video. If we're going to multiply, remember we're looking for, I'm going to highlight the top from the bottom. Okay, so here's the numerators and here are the denominators. And actually, let's use a different color so you could see that a little bit better. So let's take a look and see, are there any numerators that could go along with a denominator so that we could simplify them, make them into a different equivalent fraction? Yes, look at the 36 and the 6. Both of them are divisible by what number? 6. What is 36 divided by 6? 6. And what is 6 divided by 6? 1. Nice job. Anything else we could simplify? 5 and 6 don't go together, and 5 and 19, they do not go together. And 1 really doesn't change anything. It keeps it the same. So that is in simplest form. And so I think that's the furthest we can go. So our next step is to remember, what was the next step? When we're multiplying fractions, what do you do? Exactly, we go straight across. So we do 6 times 19, which is 114. And then 5 times 1 is 5. And this is an improper fraction. Now we need to figure out what is the equivalent as a mixed number. Because I would hate to leave it like this when the numerator is larger than the denominator. So I kind of want to put it in simplest form. And that means I want to change it to a mixed number. So over here I have shown some work on how to do that. So remember the top, the numerator falls over into our division sign. And so we take 114 divided by 5. 5 goes into 11 2 times. 2 times 5 is 10. And we have 1 left over. Now we do have a number to drop down, so let's drop down our 4 and let's subtract. Or how many times does 5 go into 14? 2 times again. 2 times 5 is 10, and we have 4 as a remainder. Now, normally, when we were changing things to decimals, we kept going until we kept adding zeros and dropping down zeros. But at this time, we are going to take our remainder and we're going to write it as a fraction. So we're going to say that there are 4 left over. Those are our extra fractional pieces, 4/5. So it'd be 22 and 4/5. Now let's try another problem. What about multiplying 4 and 8/9 times 3 and 7/11? I'm going to give you a brief moment so that you could set this up and see if we can solve this. Okay, so here's what I got. First of all, I changed 4 and 8/9 to 44/9, and 3 and 7/11 to 40/11. And what I noticed is that 11 and a 44, they go together, meaning I can create a fraction out of them, 44 over 11, and I can simplify them. 11 goes into both. So 44 divided by 11 is 4, and 11 divided by 11 is 1. And then I can multiply straight across. 4 times 40 is 160, and 9 times 1 is 9. So let's change this improper fraction to a mixed number. How many times does 9 go into 160? Well, let's start off with 9 into 16. Well, it goes in there 1 time. That's 9. And I have 7 left over. So I can drop down my 0. How many times does 9 go into 70? Well, it goes in there 7 times. 9 times 7 is 63. And I have 7 left over. So I'm going to put my little remainder up here. That's my additional parts. And so I have 17 and 7/9 as an answer. What I would like for you to do is to try these 4 problems for ticket problems for tomorrow. Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.